The Windows 11 bold at 11 Weather app consumes 1.2 gigabytes of RAM for a widget that shows 5-day forecasts and a temperature number. Open Task Manager and you'll find 9 separate processes hiding underneath. Expand the weather process tree in Task Manager. You'll count 9 separate processes, a browser process at 68 megabytes, a renderer at 662, a GPU process at 284, network service at 92, crash handler, utility processes. This is not a weather app, it's a headless browser running a website. The Weather app is a progressive web app built on Microsoft WebView 2. WebView 2 is the embeddable Chromium runtime that ships with Windows 11. It's the same engine behind Edge, packaged so developers can embed full web content inside native desktop apps. One API call gives you an entire browser. WebView 2 launched in 2020 as Microsoft's answer to Electron. Any app can embed a full Chromium browser with a single Create Core WebView 2 environment call. Native shell, WebGuts. Chromium isolates every web page into its own renderer process. If one tab crashes, the browser survives. Each renderer gets its own memory space, its own JavaScript heap managed by V8, its own GPU context for compositing, security and stability traded for memory overhead. A single page can spawn dozens of processes. When the Weather app starts, it launches the browser process first. The browser spawns a renderer for the web content. It starts a dedicated GPU process for hardware compositing. A network service process handles all HTTP requests. Then come the supporting cast, crash reporting utilities, audio service for notification sounds, storage handlers for cookies and cache, extension sandboxes even though Weather has no extensions. Every sub-process is a full OS process with kernel overhead, thread pools, and its own heap. 9 processes just to show you tomorrow's temperature. Open Edge and navigate to edge://process-internals. This is Chromium's internal process viewer, hidden from normal users. Every open tab, every extension, every background service gets a row with memory stats. The Weather app uses the exact same architecture, but you're stuck with all 9 processes all the time. The renderer alone holds 662 megabytes. The GPU process, 284, network service, 92. The browser process itself is only 68. It's just the coordinator. Run Process Explorer from Size Internals and inspect the Weather renderer process. The private working set shows 662 megabytes. Check the commit size, 712 megabytes. Drill into the heap allocations. The renderer has allocated separate heaps for JavaScript objects tracked by V8, image buffers in decoded bitmap format, layout trees for CSS box calculations. The renderer's heap holds everything needed to paint the page: JavaScript objects for weather data and add state, DOM nodes for the forecast grid structure, image buffers for weather icons, background gradients, and add banners. CSS layout trees mapping every box on screen. V8's compiled bytecode for all loaded scripts. All allocated inside one process, none shared across the process boundary. The Weather app's HTML loads external JavaScript bundles for ads, analytics tracking, weather tile rendering, and MSN integration. Each script allocates objects in the V8 heap that persist for the app lifetime. Every ad impression fetches high-resolution images and caches the decoded bitmaps. The page is a single-page app that never navigates, so the heap only grows, never resets. Every image the Weather app fetches is decoded from compressed format into raw bitmaps and cached in renderer memory. Weather icons at multiple resolutions. Forecast tile backgrounds. Ad banners rotating every 30 seconds. Promotional tiles. Background gradients. Each bitmap sits uncompressed in RAM. A single 7 of 28 by 90 ad banner decodes to over 2 megabytes. After an hour of runtime, you've cached dozens of images totaling hundreds of megabytes. No eviction policy, no size cap, no LRU expiration. A native WinUI app written in C++ or C# would share system-wide image caches managed by the OS. It would use hardware-accelerated direct composition layers shared with the desktop window manager. Font rendering happens once via direct write and gets reused. WebView 2 duplicates everything. Images decoded twice, once in the network cache, again in the renderer. font caches duplicated per process, layout engines isolated per instance. The GPU process holds the Chromium compositor. It receives paint commands and layer updates from the renderer process over IPC. It rasterizes vector graphics into textures using Skia. It uploads those textures to the GPU and composites them into frames. It caches decoded textures for smooth scrolling and animation. Then it sends the final composited frame buffer to the desktop window manager. When you open the Weather app, the browser process reads your WebView 2 profile from disk. It spawns the renderer and passes it the MS-APX Web URI. The renderer requests the HTML page from the package. It parses the markup and builds the DOM tree. JavaScript starts executing and fetches weather data from the API. Images start downloading. The renderer decodes them and paints layers. The GPU process composites everything. Open Chrome Dev Tools and attach it to the Weather app using the remote debugging port. Switch to the Memory tab and take a heap snapshot. You'll see megabytes of detached DOM nodes, elements removed from the page but still referenced by event listeners. Cached images that should have been garbage collected. Closure scopes holding on to old weather data. Event listeners never cleaned up. The page leaks memory because it's a single-page app with no navigation to trigger a full cleanup and reset. Break down where the renderer's 662 megabytes actually lives. JavaScript heap managed by V8. 212 megabytes of live objects. Image cache holding decoded bitmaps. 318 megabytes, almost half the total. DOM structures and CSS layout trees, 108 megabytes. Event listeners, compiled code, and closure contexts, 24 megabytes. Here's the trap. Progressive web apps are marketed as lightweight alternatives to Electron. Install from the browser, run like native, update seamlessly. But under the hood, you're launching a full Chromium instance with the complete process tree every single time you open the app. The browser, the renderer, the GPU compositor, network service, crash handlers, all 9 processes. The app never closes the browser engine, it just hides the window. Minimize the Weather app and all 9 processes stay resident, holding 1.2 gigabytes. Every PWA on Windows 11 is a camouflaged Chromium instance consuming hundreds of megabytes while sitting idle in the background. Microsoft ships dozens of WebView 2 apps in the default Windows 11 installation. Mail with full HTML email rendering. Calendar with event-rich views. Photos with editing filters and effects. News with infinite scroll article feeds. Microsoft Teams. Even the widgets panel. Your desktop is running multiple headless Chromium browsers at idle, each spawning 9 sub-processes, each consuming hundreds of megabytes, all invisible in the taskbar. Each WebView 2 instance duplicates the entire Chromium stack, separate V8 JavaScript engines with independent heaps, separate Skia graphics libraries for rendering, separate Blink layout engines, separate GPU contexts with their own texture caches, no shared state between instances. 5 inbox apps running simultaneously could consume 6 gigabytes of RAM before you even open a single user document or web page. Quick recap. The Weather app is a WebView 2 PWA, not a native app. WebView 2 uses Chromium's multi-process model, 9 sub-processes per instance. The renderer caches images and JavaScript objects with no eviction policy. The GPU process duplicates compositor textures. Added up, 1.2 gigabytes for a 5-day forecast. So next time someone brags about installing a lightweight PWA, remind them, it's Chromium all the way down. 9 processes per widget. No sharing, no limits. Your desktop is a browser graveyard. If you enjoyed watching this Weather app consume more RAM than your IDE, subscribe for more deep dives into the software you use every day.